For section 4.1, we're going to be looking at solving systems of equations by graphing and also by substitution. Now, if you'll remember from Algebra 2, there are actually 3 different ways to solve systems of equations. Systems of equations are 2 equations in 2 variables, so 2 equations both with an x and a y. The solution to a system of equations is any of the points that they share. So that can be 1 point, that can be an infinite amount of points, or in some cases it's no points. There's 3 ways to solve, like I said before: graphing, substitution, and elimination. You've learned all 3 of these from Algebra 1 and Algebra 2. We're going to be reviewing all 3 of them. In this particular unit, we're just going to be looking at graphing and substitution. We'll do elimination on your next set of notes. Let's start by solving by graphing. When you solve by graphing, basically what you do is you take both of the equations and you graph them, and wherever they intersect is the point that they share. In essence, that's the answer. So if you look at the problem we've got here, I've got y equals negative 4x plus 8 and 2x minus 3y equals 18. Now the first equation, y equals negative 4x plus 8, that's in slope-intercept form. So what I need to do when I graph is I need to start up here at the 8, and then my slope happens to be a negative 4. So I'm going to go down 4 and over 1. And I'm actually going to do that several times. You want to be as accurate as possible when you're using solving by graphing, so your answer is easy to see. Excuse me. So there's your first line. Now what I'm going to do is on the exact same graph, I'm going to graph the second line. And when I graph the second line, we're going to see where they intersect. And wherever they intersect is the point they share. Now this second line is in standard form, so we're going to have to solve it using standard form. If I plug in a 0 for y, the y cancels and I'm just left with 2x equals 18, and if I divide that out I get x equals 9. So there's my intercept on x, and then if I plug in a 0 for x, I get negative 3y equals 18, or y equals negative 6. So my y-intercept is a negative 6. And if we graph those through those 2 points, you'll see by looking at the graph that the point they share is right here. And the point they share is the solution. It's the point that satisfies both of those equations. So this point happens to be the point 3, negative 4, and that would be the answer to my system of equations. Now when you solve by graphing, it is possible to have no solution or infinitely many solutions. Let me show you what that looks like. Let's look up here. First of all, if it's one solution, we call it consistent or independent. And basically what that's going to look like when you graph it on an XY coordinate grid is it's going to look just like our last graph, where the lines intersect and they meet at one point. That's going to be one solution, or consistent and independent. For no solution, we use the word inconsistent. And if you're looking at an inconsistent graph, those are going to look like parallel lines. If you think about it, that makes sense. The solution to a system of equations is the point they share. If they're parallel lines, they're not going to share any points. And if they don't share any points, there is no solution. Last but not least is infinitely many, or consistent and dependent. So consistent and dependent looks, you're going to graph a line, and then when you go to graph the second one, it's going to graph directly on top of the first one. They share every single point because they are the same line, and therefore they're consistent or dependent, or have an infinite amount of solutions. Last but not least, let's look at solving by substitution. When we solve by substitution, you want to take one of the 2 equations and get it by itself. And the easiest one is the one with a coefficient of 1. For example, if you look down in the problem that I've got right here, this x has a coefficient of 1. So when I'm ready to solve this one is the one I want to get by itself. The one with nothing in front of it, or a coefficient of 1, is going to be the one that's easiest to get by itself. For step 2, you actually substitute that entire equation into the other equation. So you're putting an entire equation into an equation for the appropriate variable, and then you solve. So let me go ahead and show you this. So like I said before, step 1 says you got to solve one of the equations for either x or y. And I told you that this x was going to be easiest. So what I'm going to do is I'm actually going to minus that 3y over. So what I'm going to be left with is x equals 3 minus 3y. And I'm going to cross this out because he's no longer valid. I'm not going to use him anymore. Now these are my two equations. So if x equals 3 minus 3y, I could plug in 3 minus 3y for any x I want, because 3 minus 3y equals x. I'm going to go into the other equation and plug it in for x. So instead of 2 times x, it's 2 times 3 minus 3y plus 5y equals negative 5. So you plug an entire equation into an entire other equation for substitution. So to solve this, I would first distribute that 2 in. And then I'm going to put my like terms together, and there's no equal sign in between them, so that just becomes a negative 1y. I'm going to minus that 6 over. I'm going to get negative y equals negative 11, or y equals positive 11. So I've got half my answer. Remember, the answer to a system of equations is a point. So by getting that 11, I got my y. Now I need to find my x. And the easiest way to do that is to take the y and actually just plug it into the equation that you isolated for in the beginning. So instead of 3 minus 3 times y, now that we know y is 11, it's going to be 3 minus 3 times 11, or 3 minus 33, in this case negative 30. So x equals negative 30, y equals positive 11, and that's the solution to my system of equations.